Again, method students, we're going to have a look at the graph of y equals log e of x, or the natural logarithm of x, in this video. And similar to what we did with the exponential graph, we're going to explore the gradient of this function to see if we can try to understand why the derivative of log e of x is what it is. And I won't tell you what it is yet, just in case you don't know. So here's our curve, y equals log e of x. We should hopefully be pretty familiar with this, this curve. And what we're going to do to try to explore the gradient at various points is to draw a tangent line. And so I'm going to mark in a point here and draw a tangent line at that point. Now, just because that was the first point that came up, you can see there that it looks like the gradient when x equals 1, the gradient of this tangent line looks like it's about 1. Which it is, and we'll kind of plot that point soon enough. But just generally, if we explore this graph, well, we know firstly that we can't take the log of 0 or a negative number. So the domain for this graph is from 0 to infinity. But if we start to think about really small x values, we can see that the gradient is really quite large here. And as we move further to the right, the gradient is gradually getting less and less, right? The line's getting flatter and flatter. As we keep moving to the right, it's not ever going to get completely flat. The graph of log e of x doesn't have any stationary points, so it's not going to, we're not going to get a 0 gradient, we're not going to get a negative gradient, but as we move further and further to the right, the gradient is going to decrease. It's going to get smaller and smaller. Let's try to see if we can get a few values that are relatively precise so that we can actually plot them and see if we can figure out what the graph of the derivative is going to look like. So if we have a look at this point here, and this is actually the point where x is equal to a quarter. The gradient of this line, and you'd have to look really carefully using the grid lines, the gradient of this line is actually 4. Okay, you could find 2 points on this curve and do a find 2 points on the tangent and do a rise over run. You'd get in some way a rise of 4 and a run of 1. The gradient at this point is 4. And so if we plot that onto our graph, we're plotting the point x equals 1 quarter, y equals 4, because that's the gradient at x equals a quarter. If we keep moving a little bit further to the right, we know the gradient's going to get a little bit less. Let's try to move to the point where x is equal to a half, which is about there. And the gradient of this line now, again, if you can try to find 2 clear reference points, the gradient of your tangent line when x is equal to a half is going to be 2. The gradient of this line is actually 2. And so that means that the gradient of log e of x when x is equal to a half is 2. And so if we plot that point, where x is a half and the y value, which is now, remember these points are representing the gradient, so the y value is 2, the gradient value is 2. As we keep moving to the right, we know that our gradient values are going to stay positive but decrease. When we get to x equals 1, we saw it before, we've actually got a gradient of 1, so we can plot that as well. As we keep moving, when x is equal to 2, we've got a gradient. Now we have to look carefully at this, but again, if we try to use the grid as best as we can, we can actually see that the gradient of this tangent line is a half. So when x equals 2, log e of x has a gradient of a half. And if we plot that point, we're just continuing to build up our graph. All right, let's do maybe 2 more. Let's move across to when x is equal to 3. Again, if you use rise over run to find the gradient of the tangent line when x is equal to 3, you're actually going to get a gradient of 1/3. And finally, if we move across to x equals 4 and do a rise over run to try to work out the gradient of our tangent at x equals 4, you're going to get a gradient of 1/4. And so, we've plotted a few points here to start to get a sense of what the graph of the derivative is going to look like. I'll just get rid of this tangent line here. And what you might see is go, okay, well, those points, even just with those few points there, we're starting to get a sense that this looks a little bit like a hyperbola or something like that, right? It's got that kind of curve to it where the values are starting really large. When x is a positive number, these values are really large, and as x is increasing, these values are getting smaller and smaller. They're not going to become 0 or negative, right? Because the gradient never becomes 0 or negative, but they're going to continue to get smaller and smaller as x increases. If you actually plot the curve that goes through these points, you'll actually find that it is the line y equals 1 over x. It's the right-hand side of our hyperbola. We don't get the left-hand side of the hyperbola because we know that the domain of log e of x is only positive numbers, only positive real numbers. But this is indeed the right-hand side of a hyperbola. And so that is why the derivative of log e of x is 1 over x.